Alright, so welcome back to video series 2. Go ahead and take a moment and read the description. So it says the study in question is focused on the student population at Cal Poly. So I guess that's a population. The aim is to investigate whether the specific number a student selects influences the number of letters they can memorize from a secret phrase. Okay, the entire student body at Cal Poly forms a population for the study. However, the sample that we have access to for this study is limited to 90 students from a business class. These students participated in the study using an online app. Okay, so therefore we know our sample size is 90. A Cal Poly student is the observational unit, not a business student. Okay, take note of that. The experiment was conducted in the following manner. Each student was asked to enter a number between 0 and 50. Based on the number, one of two secret phrases was revealed to the student. The student then had 15 seconds to memorize as many letters from the secret phrase as possible without taking any notes or screenshots. Following the memorization phase, the student was given 30 seconds to recall and type in as many letters as they could remember in the correct order. After the recall phase, the app automatically calculated and displayed the number of letters the student correctly recalled. The statistical question being explored through this activity is whether the number selected by the student has an impact on the number of letters memorized from the secret phrase. So the idea here is that they're essentially getting either a phrase that the letters were all in order, which was even, or the letters, which was just random ordering of letters, which was odd. And depending on what they selected, that determined which password they saw. And if they selected even, they were most likely able to memorize it faster, or memorize all the letters. Whereas if they saw odd, it was really difficult to actually memorize those letters. So let's go ahead and go through this analysis. I guess SSVA, summary statistics, visualization, and analysis. So take a moment and pause the video and just look through the numbers and try to make sense of what you see. All right, so if you notice, we have 43 people saw the numbers in order, 47 saw it scrambled. Again, it was self-selected, so that kind of makes sense. And so it being in order was, their mean was 13.9. When it was scrambled, 8.7. So you're able to memorize more letters if you saw it in order. And the standard deviation was shockingly very similar to one another. All right, and so this is the box plot. This is a box plot that allows us to see the distribution of the two groups. With that being said, I'm going to eventually see this in a moment, but I might as well ask you now, what are the two variables? There's two variables here. What are the two variables? The two variables should be letters memorized and whether or not the letters were in order. The number of letters memorized. So the number of letters memorized is quantitative, whereas whether the letters were in order or not is categorical binary. Okay, and last but not least, this is our analysis. Okay, and this is where we would implement two independent population means tests. This is going to be our test statistic. This is going to be our degrees of freedom. And this is going to be the corresponding p-value. So with that being said, we can now answer some conceptual questions. Okay? So why don't you all pause the video again and take some time to answer these questions. So what would be the population of interest? Okay, the population of interest is going to be all Cal Poly students. The sample was 90 Cal Poly students from the business class, and a observational unit is going to be a Cal Poly student. Okay, so hopefully you all were able to get that. Not a business Cal Poly student, but a Cal Poly student. What's wrong with this? This is wrong because what's wrong with this is that we're doing a convenient sample. I gain access to only my business students, so therefore only evaluate them. This is a convenience sample. So therefore there's some inherent bias with this analysis. Question 2. What's the response variable? What's the explanatory variable? So the response variable is the variable that we're trying to understand, trying to predict, whereas the explanatory variable is being used to understand the response variable. So the response variable here is going to be the letters memorized, which is quantitative, and the explanatory variable is going to be whether they got the letters in order or not, which is categorical binary. Okay. Okay, so even was in order, and odd was that they were not in order. Okay. I'll put that. I'll say scrambled to be consistent. And then in order. All right. With that being said, question 3 tells us, or asks us, what's a research question? What we really want to know as the investigators is to determine, does the actual letters, be in order or not, have an impact on the number of letters memorized, okay? And so does the number selected by students have an impact, which is indicative of it being in order or not, have impact on the number of letters memorized from the secret phrase. And so the statistical technique that we're using is called the two independent population means test. Okay. However, it can be more specific to be either the Welch's t-test or the Pooled t-test. And so in generally, it's two independent population means, but it can be either Welch's or Pooled. And that's determined by the S ratio. Okay? The S ratio, I think that's next. No, it's not next, but it'll be coming up soon. So it says state the parameter of interest in symbols, explain what these symbols mean. So when it comes to Stat 251, we should remember that when it comes to dealing with means, we should be implementing or analyzing or using the using mu. But since we have two means, we want to see if the two means are the same. We're going to be using mu1 and mu2. Okay, so the actual thing that we're after will be the difference between these two mu's. And so one version of it could be mu e minus mu o, where e is even and o is odd, or it could be mu o minus mu e, or mu s, where s is scrambled and mu u is unscrambled, so on and so forth. As long as you're looking at the difference, you're fine. Okay? You're looking at the difference, you're fine. And so at the end of the day, when it comes to population means, you know for a fact that you can never ever know what these values are. You can never know what these values are, so you have to estimate them. Okay? And so this is how you would explain it in the context of the problem. It's the difference between the population mean of letters memorized by the students that selected even number from the population mean of letters memorized by the students that selected the odd number. As long as you're close to this idea, you understand the premise. This is the context, okay? The mean letters memorized, and then you're looking at the difference, okay? And emphasizing this idea that it's the population mean. And then this should say statistic, yeah, exactly. State the summary statistic used to estimate the parameter of interest. Remember, you won't ever truly know what the parameter of interest is, so therefore you have to estimate it with sample statistics. So using logic, what do you think the actual statistics should be? If you remember from Stat 251, the statistic for the mean is X bar. So you know it should be X bar 1 minus X bar 2, or even X bar E minus X bar O. Okay? So the summary statistic would be just the difference between the sample means, 13.9 and 8.7. Dr. Williams, where did you get those numbers from? Good question. From the R output. First of all, they're right here. These are the sample means. And then it's also right here. These are the sample means. All right, good job. And so at the end of the day, the difference between the sample means is also the point estimate. Okay, this is also the point estimate. And so when it comes to implementing hypothesis testing or confidence intervals, it's imperative that we know that our difference between our sample means is our point estimate. Okay. So now I can talk about what is the actual difference between the pool t-test and the Welch's t-test. And I'm going to scroll down a little bit and then I'm going to scroll back up. So the true difference is based off of the S ratio, which is S max over S min. S max is the standard deviation maximum. S min is the standard deviation minimum. So if S max, okay, I'll do this up here. I don't know why this is not up here. Let me just copy and paste this for our own sanity. If put this here. If the S ratio is less than or equal to 2, that means that these S max and S min are approximately close to one another. We're going to use the pool t-test. We're going to pool our variances together. And if S ratio is greater than 2, we use the pool t-test. We use Welch's t-test. Welch's t-test. And that's that. And that's that. So, why do we need two different techniques? It's how we measure the variability within our from sample to sample. And that is dictated by our standard error. Okay, so we're using the pool t-test. Our standard error is found in this particular manner, where SP squared is coming from this equation. N1 is the sample size for group 1, and N2 is the sample size for group 2, whereas S1 and S2 are the standard deviations for group 1 and group 2. Whereas Welch's t-test is a lot more simpler. It's just going to be the ratio, just this equation here. Okay? So that is the standard error, and that's the difference between the Welch's and the pool t-test. Okay? Now for question 7, it's time for us to I can just show it to you. Okay. State the non-alternative hypothesis using words and symbols. What's the assumptions? The null hypothesis is that the population means the same in layman terms, and then the alternative is that they're not the same. And so one way of looking at it is like this, saying that they're equal to 0, the difference. And then another way of saying the same thing is that they're the same. If you want to say that the alternative is A, that's fine. I just use 1 because that's how I learned it. Then using words, the population mean of letters memorized by students that selected an even number is the same as, that's the null, the population mean of letters memorized by students that selected an odd number. Whereas the alternative is that it's the same thing, but just not the same. The assumption is that data is random. Okay, some randomization is implemented in terms of sampling. And there are 2 independent groups, or random assignment was done. Based on your experience of this example, which one do you think was done? Was it 2 independent groups or random assignment? Hopefully, you would have said random assignment. Almost there, y'all. Almost there. It asks for us to calculate the test statistic from summary statistics section. Draw the distribution. What are the implications of the test statistic being more than 3.5 standard errors from 0? What type of evidence do we have? It's a lot of questions. First element is calculate the test statistic. It looks something like this. And so hopefully you were able to find the difference, the point estimate, right? That 5.2 divided by the standard error. You have to calculate that. It's a lot of work. 7.8947, which is what we got from our output as well. This is going to be, if I were to draw this, we're reaching above 15, I'm assuming, I think. If you were to draw this test statistic is positive, so it'll be somewhere here, and our p-value would be very, very small. It won't even be on this vertical line. Will not even be on the graph. It will be probably somewhere over here. I can't even select it. Our vertical line will possibly be over here because it's 7, right? And then the area underneath the curve is our p-value will be very, very small. So whenever our test statistic is above 3.5 for symmetric unimodal, again, I'll say this again. Whenever our test statistic is above 3.5 or below negative 3.5 for a symmetric unimodal distribution, that implies that our p-value is extremely, extremely small, indicating that we should reject our hypothesis and that we have extremely strong evidence against it. Then, state the point estimate, calculate and interpret the 99% confidence interval. I'm going to pause it. I had to take a break. So therefore, I wouldn't be mad if you took a break. So that being said, state the point estimate. Okay, it's the difference between the sample means. Calculate a 95% confidence interval for the parameter of interest. Degrees of freedom is going to be the sample size plus 1. Sample size of 1 plus the sample size of the other minus 2, which gives us 88 because our total sample size is 90. And then the critical value for a 99% confidence interval is degrees of freedom is 88 is going to be 2.6329. What assumptions need to be made in order to implement this statistical technique? Let's do it. So a point estimate is going to be 5.2 like we did before. The math behind it, I'm going to show a little bit more. This is really terse. It's going to be plus or minus our critical value times our standard error. Okay, so that's how I got these values. So I'm going to take that 2.6329 and multiply by our standard error. I didn't show how to do that, but you should be using the pooled, which is a little bit of work. Use this equation, okay? And then from there, you would add and subtract that from 5.2. You get 3.48 and 6.97. So we are 99% confident that the difference between the population mean of letters memorized by students that selected even from the population mean of letters memorized by the students that selected the odd number is between 3.48 and 6.97. Notice that 0 is not a plausible value, indicating based on our data, it's not plausible for there to be no difference between the two population means. Based on the data, it is not plausible for there to be a difference between the two means. For there to be no difference, okay? And again, the assumptions are the same as the previous statistical technique, hypothesis testing, okay? And then what are the implications of 0? I already mentioned it. If 0 were to be within the lower bound of bound, that would indicate that it is plausible for there to be no difference between the population mean. Since 0 is not within the lower bound and upper bound, there is a difference between the population means based on the data. How was that? 18 minutes? That was long. That's why we have to put all these videos in one and not put all these concepts in one. So one video, 18 minutes. Thank you.